In this lecture, we're going to explore some things you need to be aware of if you want implicit conversion support for your logical operators. And one thing I want to remind you is something we have said in the last chapter. When a binary operator is set up as a member function, implicit conversions are not going to work for the left operand. Because if you remember, the left operand is the current object on which you are calling the operator function. So implicit conversions can't really work there. If you want implicit conversions, the only choice you have is to do your operator functions as freestanding non-member global functions. So suppose we have a class called number, which is going to be just wrapping around an integer here. We're going to have a constructor, which is going to take an int n. The constructor is going to be explicit because we don't want this used in implicit conversions. Suppose this is something important for your program, and we're going to just have an operator less than done as a member function. If we try to run code like we have here, the first line here is going to work because it's just going to be comparing number objects. The first operand is going to be an explicit number object. The second operand is going to also be an explicit number object. So we're going to be calling operator less than on n1, and the second parameter is going to be n2 here. The problem is going to come if we try to do the second statement here. The first operand is not a number object, it is just a literal 15, and we want to compare it with n2. And suppose this is code we want to work in our program, because we really know that we can convert a literal int to a number because we have a constructor that can do that. The only problem is that the constructor is not explicit, so we can't use it in an implicit conversion. One possible way we can make this work is to explicitly cast this 15 to a number. We can do that, and that's going to work. But that's going to make our code ugly and hard to work with, especially if your users are doing this a lot of times in their program. You don't want them to do a lot of static casts. So one way we really have around this is to do our operators as freestanding non-member functions. But even then, that's not going to do implicit conversions because if you remember, our constructor explicitly prevents us from being used to do implicit conversion from a net. That's what the explicit keyword here is saying. So even if we do our operator as a non-member, the compiler won't be able to transform the 15 that we have in our code here to a number object using the constructor we have in there. So this is still going to give us a compiler error. And some of you must be thinking, can't we use the std_rail_ops namespace we saw in the last lecture? I want you to try and think about this. And my answer is that's not going to work either. So why is that not going to work? Because we are calling our function with parameters of different types. The first one is a net, the second one is a number in this case here. So the function template is going to be confused because all these templates take the same type for the first parameter and the second parameter. If you remember, they were of T type. And here we are passing different types. So the two things here are not going to work and they are going to give you a compiler error. The compiler is going to see that it can generate a template instance for the first call we do here, and it may generate that, but still the two last lines here are going to give you a compiler error, and that's not going to work. The only choice we have really is to set up overloads for our operators to take into account these operands that we pass here. So we're going to do an overload that takes the first parameter to be a net, and we're going to do another overload that takes the second parameter to be a net, and that's going to work. But the problem is each operator is going to have 3 overloads. And if we overload all the 6 comparison operators, we're going to end up with 18 operators just for the number class. And this is really crazy. The C++ guys saw this problem and they introduced a new feature in C++ 20 that we're going to be learning about starting in the next lecture. But for now, I just want you to see how crazy this is. And we're going to set up code that uses all these 18 overloads. So what we will do, for example, is set up an overload that takes the first parameter to be a number and the second parameter to be a number. We're going to set up another one which takes the left operand to be an int, and we're going to do another one that takes the second parameter to be an int. And we're going to be repeating the same thing for the other operators. And in total, we're going to have 18 operators. One set of overloads for less than, one set of overloads for equals, one set of overloads for greater than, and all the other remaining operators. And only then is our code here going to work. So let's head over to Visual Studio Code and play with us a little more. Here we are in our working folder. The current project is logical operators with implicit conversions. We are going to grab our template files because we're going to be starting from scratch and set up a number class to play with us. And we're going to put the template files in place, and we're going to open this little guy in Visual Studio Code. Let's do that. We are going to open our main CPP file and clean it up a little bit. And we are going to set up our number class. We're going to put in the number header file, and we're going to put in the number.cpp file. I am going to hop over to the header file and put in my class. It is a simple class, number. That's the name for the class. And it's just going to have one single member variable, which is a net. We have a constructor, which is explicit. We have a getter here to get the wrapped int if we want that. And we have a dummy destructor here, which is really not going to be doing anything, but we're going to keep this in anyway. And we have our output stream operator, which is just going to print this number here. Nothing complicated. We are going to hop over to the CPP file and also put in the code. We have the implementation for our constructor. We have our output stream operator, and we have the destructor implemented here. Nothing complicated. Now, we want this class to support our operators and support implicit conversions. And the ultimate goal is that we could go in our main function and, for example, include our number class. We can do that. Let's say number. And we can hop over in our main function and use code like this. So we could set up two number objects and compare them like we do here on line 11. This is going to work because we have a less than operator, but we also want implicit conversions to kick in when we use literals on the left or on the right here. We want this to work. So this is what we're going to do. We're going to hop over to our number class. We are going to put in all the operators that we would need for implicit conversions to work. And you can see that this is a really large number of operators. We don't want this comment here. We want these guys to work now. So we have the overloads for less than. One overload is going to take two number parameters. The other is going to take a left operand, which is an int, and we're going to have a second operand, which is a number. The third one is going to take a net in the second position, and the first operand is going to be a number. We're going to be copying this pattern on the other operators. For example, equals follows the same pattern. We have the greater than operator, the greater or equal operator, less or equal operator, and we have a not equals operator here. And this is really crazy. Look at this number. This is really bad. We don't want to be able to do something like this. But I want you to see the bad way to do things before I introduce you to the new cool and shiny features of doing this in C++20, which is the three-way comparison operator we're going to be starting to learn about in the next lecture. So let's hop over to the CPP file and put in our implementations. We are going to go below the output stream operator and we're going to say comparison operators to make this easier to follow. And I am just going to paste these in because they are really doing nothing special. They are just appearing in a large number here. This is the only special thing about these operators. So the first variant is going to be comparing two number objects. We're going to grab the wrapped int and compare it. If one is less than the other, we're going to return true. If it's not less than, we're going to return a false. The other one is going to use the left operand as a net. So we're going to grab the left operand directly and compare that with the wrapped ant in the second object. This is the comparison we do here, and we do the same thing. We just have the ant in the second position here, and all the other operators are going to follow this pattern that we have here. You don't have to type all this code in because this is really a lot of typing. You can grab the code from the resource section of this lecture. You can download that and paste that in your project and really see how bad things can be if you don't have the features we're going to learn about starting in the next lecture. Let's go back to the main CPP file. Now this should work because we have an overload to take the first operand as a net, and we have an overload to take in the second parameter as a net, and this is going to work. If we build and run this code, this is going to work. Let's build with GCC because that's what we have been doing all along, but Clang here is also going to work. Let's wait for it to finish its job. You see the build is good, but we can also use GCC. No harm in that. So let's use GCC. And the build is going to be good. We can clear and bring up a PowerShell window. And if we run Rooster, we're going to see that the program is going to run, and it is going to say that N1 is less than N2. This is going to be true. 15 less than N2. That's also going to be true because 15 is less than 20. We're going to see if N1 is less than 25. N1 is 10. So 10 is less than 25. This is also going to be true. So our program is working. But the point is the number of overloads you had to put in to make this work. It is possible to do this in a much easier way, as we are going to see in the next few lectures. But I wanted you to see how crazy this can be if you don't have the features we have in C++20 now. This is really all I wanted you to see in this lecture. I hope you found it interesting. We are going to stop here in this lecture. In the next one, we're going to learn about the three-way comparison operator, which was introduced in C++20 to solve this exact problem we saw in this lecture of having just too many operators to solve a seemingly small problem that we have of comparing stuff and having implicit conversions work. So go ahead and finish up here and meet me there.